Hello everyone, how are you? I hope you all are fine. And this video we will revise for the quarter exam. In this sheet, you will find all the rules you may need in the exam and the materials you should covered for the exam. You should study before you go to the exam. So here are the topics: multiplying, dividing rationals, and so on. Okay. After I finish this sheet, I will upload this with the solutions, and I may add some rules in this area. So this would be final. Okay, don't forget to bring your calculator, please. Let's go. Okay, the first type of questions by Pythagorean theorem, we said that if we have one missing of the two legs of the right angle and we have the hypotenuse. Hypotenuse is also opposite to the 90 degrees angle, so this is the hypotenuse. To find the missing side here, use the Pythagoras theorem by subtracting 15 squared minus 9 squared. Using a calculator, you will do this and the answer will be 12. The same idea here, but here you need to find the hypotenuse. So to find the hypotenuse, you add, because the hypotenuse is the biggest side in the triangle. You add 5 and 12 squared, then take the square root. The answer will be 13. Please remember the sohcahtoa. Here we have tan, so tan is opposite over adjacent. Okay, opposite over adjacent. For what? For which angle? Angle A. So in this case, angle A is here, and this is the opposite, and this is the adjacent. We said that this is the hypotenuse in all cases. So the ratio of the opposite and the adjacent for this angle is 32 and 24 to 24. When you simplify this, it's 8 over 4 over 3. When you divide both by 8 or using calculator, this would be 4 over 3. But remember that the reciprocal for tan is cotan. If he asked about cotan, you take the reciprocal 3 over 4. Sine, so it's so opposite hypotenuse. For which angle? Angle Z. This is opposite, 21 over 35. Divided by 7 is 3 over 5. What's the reciprocal function of sine? It's cosec. So if you ask about cosec, you should write 5 over 3. Here we have a right angle. Right angle, it means we can use sohcahtoa. And we have here missing angle, so we use sine minus 1 or cosine minus 1 or tan minus 1 by pressing shift sine or shift cosine and so on. So in this case we have the opposite to the angle and the adjacent. So the opposite and the adjacent, we can use the tan function, the tan ratio, which is 49 over 41. Please do not switch between the two values. Don't try it 41 over 49, because this will give you this angle, because this angle, the opposite is 41, the one which you put in the numerator. So this is the right formula to write on, to use the calculator to find the missing angle. Shift tan 49 divided by 41, it's 50 point, so it's 50 when you round it to the nearest degree. Here we have missing angle, and this is the opposite, and this is the hypotenuse, so it's shift sine 21 over 22. The guide answer for all these answers will be at the end of the sheet. Okay, here we have a missing side and it's a right angle, so use sohcahtoa. And in this case, for this angle we have the opposite and we missed the hypotenuse, so we said it's opposite and hypotenuse, we use sine. You should write this on your paper. The first step, you should write it on your paper. Sine 35 should be 13 over x. This will help you to use the calculator in the right way, because when you do cross multiplication, the x will be replaced with or will be switched with the sine 35, and it will be division sine 35. But if the x was in the numerator, you can multiply, like the next one. This is the opposite and this is the adjacent, so it's toa, and in this case tan 18 equals x over 13. In this case, you can multiply 13 with tan 18. 13 tan 18. You cannot multiply 13 with 18. It's one value. 13 multiplied by tan 18 on the calculator. Don't write x on calculator. Write this only on the calculator, as I will show you now. 13 tan 18. If you found any errors by using calculator, you can close the brackets to find the exact value. 4.2. Okay, here we have some easy questions about coterminal angles in degree, or coterminal angles, for example, in radian. Okay, so the full circle in degree is from 0 to 360, and when you add a higher value than 360, you will go back again in this range. So for example, if you have an angle like 50, if you added 360, this will give you a coterminal angle to this, which is 410, and so on. Or if you subtracted 360, you'll have a coterminal angle for the 50. The same here, if you have a small angle, it's negative at 360, so the answer would be 330. This is too big, it's over 360. You can subtract 360 to find the coterminal angle for the 420 in this range, which is 8, oh sorry, oh yes, 60. So easy. We have the same idea for the radian system. Instead of adding or subtracting 360, you can add or subtract 2 pi, because it's equivalent to the 360 in the degree system. So you can add or subtract 2 pi. You can see that this is bigger than 2. So if you divided 29 divided by 6, the answer will be more than 2. If it's more than 2, you need to subtract. So in this case, you subtract 2 pi. Another way, you can find that the numerator is more than double the denominator, so you know that you need to subtract. You have to subtract. But if you subtracted and you didn't find a normal, 29 pi, here's the pi, over 6, then minus 2 pi. Okay, this is 17 over 6 pi. It's not in the options. It's not one of the options. So you can still subtracting 2 pi, because it will still give you coterminal angles, coterminal values. So this is 5 pi over 6, and it means you can subtract more than one time, or you can add many times, 2 pi or 2 pi, 2 pi or 360, and so on. So this is the answer. Here it's clear that you need to add 2 pi. To convert from degree to radian, here you have a number, a degree, so and your answer should include pi. It means you need to put the pi in the numerator over 180. Why 180 and pi? Because they are equivalent, and it will switch from the degree system to radian system. If you try this with the calculator, this will give you the value in the radian mode. Pi over 180. I know it's not written as pi. Shift, and this is 10 over 9 pi, or 10 pi over 9, this one. You have pi, and this is radians. You need to switch to degrees, so instead of writing pi over 180, it's 180 over pi. To remove pi, you have to divide, it's logic. So 3 pi over 4, maybe 135, I don't know. 3 pi over 4 multiplied by 180 over pi. This is 135, yes. You should know that the unit circle, or the circle, is divided in 4 quadrants. This is the first, second, third, and the fourth. The first starts with 0 to 90. For all values between 0 and 90, they all lie in the first quadrant. For example, 85, 21, all these between 0 and 90. More than 90, when you go more than over 90, you have to be before 180. This is the second quadrant. For example, 120, 130, and so on. More than 120, 180 and less than 270, you will be in the second quadrant. The fourth quadrant will be from 270 to 360. So for this case, instead of going clockwise, which is a negative direction, or going more than 360, okay, you can find a coterminal angle. Coterminal, it means you can add or subtract 360. In this case, you can add 360 many times. So add 360 twice to negative 450, I guess. 15 plus 360, it's negative 55. You can add another 360. This is 305. The 305 would be in the in the fourth quadrant. But in this case, it's easier to convert this in degree. Okay, this would be 30, I guess. 30 in the first quadrant. So you have the chance to make it easier, or you can notice that 0 or 360, it's 2 pi, so 180 equals pi, and each 90 was pi over 2. This is pi over 2, this is pi, and this is 3 pi over 2, like 1.5 pi, and this is 2 pi. Pi over 6, it's less than pi over 2, so it means it's in the first quadrant. It's up to you to convert it to degree to make it easier, or to use the circle by the radian mode. This red angle, it moved through 90, another 90, so it's 180, straight line. Then you can add this part. This part is a missing part of from 90 after we subtract 75, so it's 15. So you can add 180 and 15, which is 195, or you can use the 3 quadrants, like 270, as we said this is 270, then subtract 75, this will give you a 95 also. Here we have 0, pi over 2, pi, 3 pi over 2, and we need to add pi over 4. So it's 3 pi over 2 for 3 quadrants plus pi over 4. Okay, we said that the reciprocal of the sine is cosec. Sine, the reciprocal 1 over sine is cosecant. So the one that starts with s, the reciprocal starts with c. So the sine, if we have the cosec, you switch this to be 4 over 5. Tan and cotan are reciprocal, so tan will be 2 over 1, which is 2. If you need to find the cosine, if you are given the sine, so the sine is opposite over hypotenuse, right? And cosine is adjacent over the hypotenuse. So you don't have the adjacent here, but you have the opposite. For example, if the angle is here is 5 and the hypotenuse is 13, if you miss one of the two legs, as we started the revision, you need to use Pythagoras theorem. 13 squared minus 5 squared, this will be 12. So in this case the adjacent is 12, so this is 12 over the hypotenuse, which is 13, so the answer is B. Okay, let's stop here and try to add the rest of the revision in another video, and I hope you enjoyed the first one.